Okay, so we are going to talk about this lesson. So we're going to do this card sort a little bit differently. So these are the values that you would see on your card sort. Okay, so in this particular activity, we're focusing on inputs. So if you remember from the last unit, we had A of S equals S to the second. So that defines the function. So A of S is your input. S squared is going to be your output. So like mentioned, we're focusing on the possible input values. So in other words, the inputs are talking about the side length. So which of these could possibly be side lengths of a square and which ones could not be possible side lengths of a square? So if we go through each one of these, I think we can all agree that any positive number could be a side length to a square, whether it's a decimal or whether it's a fraction. Impossible ones would be your -3 and your -18. We cannot have negative lengths. And then 0 can be kind of argued as impossible or possible. I kind of think, well, if it's 0, then you don't even have a square to begin with. But you could have a side length of 0, but again, you wouldn't have a square to begin with. So 0, I believe this textbook or this resource puts it under a possible input. So this could be all possible positive values, including 0. Okay? If we look at the next piece, again, we're using these same numbers right here. We are talking about a tennis camp. Charges $40 per student for a full day camp, and the camp runs only if at least 5 students sign up, and then limits the enrollment to 16 campers. So that's the most number of campers. The amount of revenue in dollars that the tennis camp collects is a function of the number of students that enroll. So we are charging, or the camp is charging $40 per student. So the student, or the number of campers, is representing your input. So if we go back up to this table of values, can we have 9 students or 9 campers based off of this from 5 to 16? Yes. Can we have a fraction of a camper or a decimal of a camper? That would be a no. Can we have a negative number of campers? That would also be a no. So we have some other positive values here. So if we look at this, we have a 9. Yep, 9 is between 5 and 16. So that is a possible. And I'm going to kind of zoom out here maybe. Maybe. Oh, wrong way. So you can see the numbers. So 9. Again, we talked about cannot have fractions or decimals. 15, yep, that works because it's within our range as well, within our values. Cannot have 0 because it has to be between 5 and 16. Cannot have a fraction. 4, nope, because it's not at least 5. Nope, nope. 6.8, nope. 72 is way too many, and again, we cannot have any negative values. So I would put impossible values would be numbers like negative numbers, decimals, fractions, and values greater than 16, values less than 5, okay, because we have certain constraints that we have in this problem. If you look at the next one, number 3, so the relationship between temp in Celsius and the temp in Kelvin can be represented by a function of K. So our input, again, is going to be degrees Celsius. So possible inputs, actually, all of these values are possible inputs for Celsius. So all values could work for your possible inputs with this one. Impossible would be no values. Okay, so understanding what your inputs can be. So even though you have a whole bunch of numbers to choose from, not all of them are possible inputs.